We now call Aran and Anthony on the stage. They come to us from the Athénée in Luxembourg and defend their project titled Aran, a new system for license plate detection. They have come up with 3 different license plate detecting systems. Good luck.
So Aran, our new system for license plate detection. So ALPR, or automatic license plate recognition, is a technology that uses character recognition, and its purpose is to produce vehicle location data. Our aim is that we want to compare the ranges of several automatic license plate recognition systems of today, create a new and better system, and test its limitations on accuracy and range. There are many current problems with the current license plates, especially during the COVID-19 pandemic. Everything has become more digital, except for license plates, which are not even connected to the internet. And this is very hard to monitor on a large scale, and it would require a lot of data and effort. Authorities also have to use a separate software to search for individual license plates. And another big problem is that all the driver license information is stored in one large database and is very easy to hack. So this is the process of a speed camera nowadays. So the car is on the road, then it acquires an image, and then this image is sent into pre-processing and sharpening, which then is sent to the processing of digits, which finally the result is a text, which then we still have to send that into a third-party application to receive further information about the driver. So this is our solution, where we have integrated the driver's information into a QR code on the license plate.
So since we are connecting the license plate to the internet, we need strong security to avoid hacking, as this will hold a lot of important information, such as the driver's criminal record, their age, address, phone number, email, etc. So this is a quick explanation about how it would work. So we have an emoji here, or a file, and then through a hash function, it goes through a long 32-digit or bit hash. So this hash can also be reused and through another function and come back to the initial point. So we are using a special architecture here, and essentially it's one where we have 2 separate aliases. So for person A, or person number 1, the letter A is equal to 1CW, while for person 2, A is equal to 7US. So what this means is that if for person A, his alias is found, it doesn't affect the rest of the user base. So we implemented this architecture into our entire blockchain model. So at the very beginning, for the sake of simplicity, we've called it Jonk Fuerscher 123 is the password, but it would actually be a file with all the driver's information. So there would be a table where the bits are calculated, so it would come into 0 and 1s, and then there would be a 50% inversion. So this is based on the buzz hash sequence, and this is where it's known to be very long and elongated and creates a lot of noise, so that it's very hard for hackers to get it. And there's a rotation after each character. So in our design, we've created a rotation after every 4 digits. So if there's a digit 010101, the 4th digit in our system would be 010001. And the instructions for this would be held in a decentralized network. And then finally, it's converted to a letter format with the same architecture as we saw earlier. So what this would, in conclusion, mean is that if you want to get my driver's information, you would have to hack 4 other people. So one person with my 50% 0 and 50% 1, then one from my 50% inversion, one to get the way that it was rotated, and then finally there's a conversion letter-based format person. So this would really prevent all large-scale hacks. So after this, our goal was also to compare our strength between our range system versus other ones in the market. So we added a handwriting detection system, which is based on MNIST database. And it's 60,000 28 by 28 handwritten digits. So we're rated for 99% accuracy. And essentially, you would draw it in. So this is a very crooked 7. And it would detect it. Unfortunately, since it's 28 by 28, it doesn't notice the small little details in the text. So if you make a 3 with a very small extrusion, it'll be quite hard for it to find out. So we found in the real world, it's tested a little bit lower. Then we have a YOLO v4 model, which is a state-of-the-art model where we have 1,500 image training from Google open source dataset, and we have full pre-processing, and we are rated 86% accuracy. So the way it works is we start at the top, and we have the initial image. Then we apply a Gaussian flare, so this is basically a grayscale, and then we have the Otsu method. So this converts it to black and white, and then with that information, we find the contours, and with the contours, they're filtered. Because if there's a small contour in the corner, that's the L in the Luxembourgish license plate. So after that, this is curated and added to a new file for detection. So after testing our model, we found that our model is 350% better than our handwritten model and 50% better than the YOLO v4 model at a long range. We tested it at different lighting, at different ranges, 10 times per data point. So thank you.